Chapter 8, Right Triangles. Today we're going to cover Section 8.1, Day 2. Your class opener is to simplify the following. Theorem 8.1. If the altitude is drawn to the hypotenuse of a right triangle, then the two triangles formed are similar to the original triangle and to each other. So it's really saying this. If you start off with this large right triangle and you draw in the altitude, you end up making other similar triangles. So the large triangle ends up being similar to this smaller green one, and it's also similar to, let me change the color so you can see it. Go to this purple one over here. So the large yellow one similar to the green one, also similar to the purple one. It says, name the similar triangles and explain why they're similar. So I'm going to start with the large original triangle, which is triangle ABC. And it's similar to the green one. And if I want to name it in the same order, well, angle A in the large triangle is the same angle A in the little triangle. B was the 90-degree angle, and in my green triangle, the 90-degree angle is D, and then B. And the big reason why it's similar is both of those triangles share angle A, and they both have a 90-degree angle. Well, now if I look at the large triangle again, ABC is similar to, and if I try to match it up to the purple triangle, well, the large triangle and the purple triangle both share angle C, so that's going to be the last one. And in the large triangle, angle B, which is the 90-degree angle, is going to be angle D in the other triangle, and then that means it's going to be BDC. Well, if triangle ABC is similar to triangle ADB, and it's also similar to triangle BDC, then all three of them happen to be similar to one another. So my large triangle is similar to the small triangle ADB, which is also similar to sort of the medium-sized triangle up there, BDC. Okay, Corollary 1. When the altitude is drawn to the hypotenuse of a right triangle, the length of the altitude is the geometric mean between the segments of the hypotenuse. So if I think of what this is saying, the altitude is going to be the geometric mean between these two pieces. So that sort of works out in a problem like this. If AD is 8 and DC is 2, find BD, and I'm going to call it X. Well, I know if BD is supposed to be the geometric mean, I find that by putting X diagonal this way, and I fill in the other two values, 8 and 2, and I cross multiply. X squared equals 16. Take the square root, and I only care about the positive value of 4 because I am looking at a side length in a triangle. So BD is 4. Corollary 2. When the altitude is drawn to the hypotenuse of a right triangle, each leg is the geometric mean between the hypotenuse and the segment of the hypotenuse that is adjacent to that leg. So here's what this one is saying. This side is going to be the geometric mean between AD and the entire length of the bottom. Okay? Likewise, BC would be the geometric mean between DC and the entire bottom. So let's look at a sample problem. If BC is 10, so I'm going to highlight this the other way. So they're now giving me BC. So this side should be the geometric mean between DC and the entire bottom. So BC is 10, DC is 5, and they want me to find AD. Okay? So AD is X. But I really need the entire AC, which is going to be X plus 5, when I set up the problem. So now setting up. I know BC 10 is the geometric mean, and it's the geometric mean between DC, which is 5, and the entire bottom, which is X plus 5. And now it's time to cross multiply, and remember, if you want to, I can reduce a little bit beforehand to make it a little bit easier. And if I cross multiply, I get 1 times x plus 5, which is x plus 5, equals 2 times 10, which is 20. Subtract off the 5, and I get 15. So I've now found that AD is 15. Find the values of x, y, and z. Well, let's see. I know that y is the geometric mean between 3 and 7. So I'm just going to start with that one. So y is the geometric mean between 3 and 7. So if I solve that, I get y squared equals 21. Take the square root. All right, now I have to think, can I simplify the square root of 21? And it doesn't split up at all. So I end up with just y equals the square root of 21. Now I go back to my problem, and I want to figure out what x is. Well, I know x is the geometric mean between 3 and the entire bottom, which I know is going to be 10. So let's write down that one. So x is the geometric mean between 3 and 10. Cross multiply, x squared equals 30. Square root each side. And I think if I can simplify the square root of 30, and I'm just going to have to leave it. Back up to my original problem. Trying to find z. And I know z is the geometric mean between 7 and the entire bottom, which I know is 10. So let's set that problem up. Geometric mean z between a 7 and a 10. So cross multiplying, z squared equals 70. And I square root each side. And I can't simplify the square root of 70, so it's going to stay the square root of 70. Find the values of w, x, y, and z. Looking at the problem, I don't know where the best place to start is, so I'm just going to start looking at the information I have. I know that 6 is the geometric mean between w and 18, so let's use that to figure out w. So 6 is the geometric mean between w and 18. I can reduce by 6 and cross multiply and get 3w equals 6, which means w equals 2. And if I come back up to the picture, well, if w is 2 and the entire length over here is 18, that must mean that x is going to be 16. Now that I know those two, I can use that to figure out y. So I'm going to fill in that I know that w is 2 and x was 16. And now if I try to figure out y is the geometric mean between 2 and 16. And let's cross multiply. Y squared equals 32. Take the square root. I can split the square root of 32 into the square root of 16 and the square root of 2. I know the square root of 16 is 4. And the square root of 2 I have to leave. Right, so now I know y as well. Well, how am I going to get z? Well, I know z is the geometric mean between x and 18, and we know that x is actually 16. So let's set that up. So geometric mean z is for 16 and 18. Z times z is z squared. And instead of multiplying the 16 and 18 together, you might have noticed this on the last one, After you multiplied the 2 and the 16, it gave you 32, and you split the 16 right back up because you knew the square root of 16. So I'm just going to leave this as saying it's 16 times 18, because when I take the square root, I know what the square root of the 16 is right away. So I'm just going to leave it as the 16. So square root of z squared is z. Square root of 16 I know is 4. And the square root of 18, well, I know the square root of 18 is really the square root of a 9 and the square root of a 2. So the square root of 9 is 3. Can't do anything with the square root of 2. Multiply the 4 and 3 together, and you get that z is 12 square roots of 2. And your closure. Explain how to find the geometric mean between two numbers.